Hi, my name is Tom Lever. In this video, I'd like to present part 6 of Little YOLO version 4 and how darknet and YOLO version 4 convolutional neural networks work. In this video, let's go over the method loadAlphabet. The purpose of loadAlphabet, roughly, to me, is creating a two-dimensional array of ASCII alphabetic characters between the space character with index 32 and character with index 126, the tilde. So we're creating a two-dimensional array of all of these alphabetic characters. I imagine the horizontal to contain 8 different sizes of alphabetic sequences, and the vertical to represent the actual characters. So the smallest space would be in the upper left hand corner, and the largest tilde would be down in the lower right hand corner. The next diagonal from the upper left would be the second smallest exclamation point. And then the next diagonal down would be the third smallest double quote. Looking in this Little YOLO version 4 folder, in the data folder, that includes coco.data, or coco.names, excuse me, which we already looked at, and the dog, which is our main testing image. Here we see our labels folder also. And this basically presents all of the images that we are going to load into our two-dimensional alphabetic array. The top row is going to contain 8 white space characters of different sizes, all with index 32, and their size delineated by a number 0 to 7. And then the second row in our two-dimensional grid is going to contain exclamation points of different sizes, 8 of them. And then we have 8 different single quotes and 8 different pound signs, and on and on. Okay, so how do we move from files, image files of alphabetic characters, to a two-dimensional array in RAM containing these alphabetic characters? We're going to minimize this, and this line begins it. So loading back up Little YOLO version 4 for viewers. First, let's declare a pointer to an array of pointers to image objects. Each pointer in the array of pointers will point to the first image object in one alphabetic sequence corresponding to one size. And this main pointer we will call alphabet. Now we need to declare define the image object template in a header file. Let's do that. This will be a C class or a struct image object with an alias of image. And I have this memorized, it's easy. We can also look here, but the image object will have a width measured in pixels, a height measured in pixels, a number of channels, R, G, and B, which is 3 for color images. And this image object will contain a pointer to a memory buffer containing all of the pixel values. In my conception, there is one R value or one G value or one B value. And that is 1 pixel, as opposed to a pixel being a triplet. So we've defined our image object template. It's included in test detector. Okay. And then let's define our pointer to an array of pointers to alphabetic sequences of different sizes. This pointer to an array of pointers will just be the output of the method loadAlphabet. Now we need to declare and define loadAlphabet. Go to the method. It's up here. This method returns a pointer to an array of pointers and has no input arguments. Now let's define the method. Okay, so in essence, to create this two-dimensional null array of alphabetic characters corresponding to 8 alphabets of different sizes and all of the physical alphabetic characters with indexes ranging from 32 to 126. Basically, for each spot in our two-dimensional array, we acquire the indexes of that location, I corresponding to the alphabetic character in the vertical, and J corresponding to which size, finding the corresponding relative path to the project file, little YOLOv4 for viewers.vcx proj, and then we call a load method, handing it that path, which then creates an image object for which we've defined the template based on the file corresponding to that path. It loads the image object and it stores it in a large two-dimensional array of image objects. So let's work through this. First, I'm going to do just a little bit of reordering here and begin. Okay. So first, let's define the number of sizes corresponding to the number of different, say, pound signs, which is 8. And then we declare a pointer to an array of pointers that we will eventually return. In test detector, it was called alphabet. Here in load alphabet, it is called alphabets. That was Joseph Redman's choice. And then we define this pointer to an array of pointers. First, we allocate memory for 8 64-bit pointers. And they don't need to be null pointer. And then the allocation method xmalloc returns a pointer to 8 64-bit objects, and that's compatible with this pointer being interpreted as a pointer to pointers to image objects. Now we need to include xmalloc. Okay. These are just declarations of a for loop index across all of the characters in the vertical of our two-dimensional array, and a buffer which will be written and rewritten with the path, the relative path to one of these character images. So let's make those declarations. And this string will always be this long. Where this value is 2 digits and this is, oh, actually no, that's not true. This will be a 126 at some point. Anyway, this string will be about this long. And we just allocated a character buffer, character array for 256 characters, which is unnecessarily large but very small relative to RAM. So for each size of alphabetic character, let us define the pointer in the array of pointers. Each pointer will be to an alphabetic sequence, so an array of image objects. So the jth pointer in the buffer pointed to by alphabets is first allocated as the memory to which that pointer points is allocated for 128 image objects, which is more than we need, but again, small relative to RAM. And then the allocation method returns a pointer to this buffer for image objects, and that pointer is stored in the array of pointers at the jth location. Then iterating over characters 32 to 126 in the ASCII table, we store in our character buffer buff the following string with, let's say, character number 33 and the third size, which is a mid-sized exclamation point. And then we need to include the standard input-output library. Then let's store the image corresponding to this path in the cell of our two-dimensional array of images of characters at the jth size and the ith character. So again, up here would be the smallest white space character. Down in the opposite corner would be the largest tilde character. The next diagonal down would be the next to smallest exclamation point. The next diagonal down would be the third smallest double quote. The next diagonal down would be the fourth smallest pound sign. So this method, load image color, loads an image object from a file corresponding to this string, and then this statement stores that image object in the two-dimensional array of alphabetic characters. And then, just to complete load alphabet definition, we return our pointer to an array of pointers to alphabetic sequences, or we return our two-dimensional grid of alphabetic characters to test detector which then is used by Draw Detections version 3 to present the bounding boxes and class names that overlay the dog and the bicycle and the potted trash can in our test image. In the next video, I would like to go over load image color briefly and a custom method that I wrote called imread convert color and create image, which I think is much more readable and compact than load image color and its submethods. See you in the next video.